Escomatic coil-fed automatic lathe, model D2 and D4. Setup operator training system. Lesson number 11, basic tool adjustments and sharpening. Before starting work on the rotating tool head, make sure the main camshaft and two tool cams are at the zero reference point. Now check your layout sheet for the information on tool number 1 and tool number 2. Located on your layout sheet is a drawing of each tool. The drawing will specify the important width and angles of the tool cutting edge. Before mounting the tools, check the tool width with a micrometer. The tool width should be within the specifications on the print. Note the tolerances shown on the tool width. It is important that the tool meets these specifications. Clean off the tool holders and the triangular tool mounting holes. If necessary, use compressed air to clean the tool holder area. Mount tool number 1 into its tool holder. Push the tool all the way back into the tool holder. Lightly tighten both set screws to hold the tool in place. You must still center each tool. The tools must be able to move when the centering screw is turned. Install tool number 2 in the same manner. Check each tool for clearance between the tool and the bushing. If necessary, loosen and move the bushing to provide clearance. Next, lock the tool head from rotating by using the tool head lock lever. Loosen the counterbalance lock nuts on the back of the tool holder shaft. Tool number 1 counterbalance unit lock nut should be turned toward the large counterweight end of the counterbalance. Unlock the tool head and rotate the tool head to access tool number 2's counterbalance lock nut. Turn the counterbalance lock nut toward the large counterweight end of the counterbalance unit. Loosening the counterbalance lock nuts will allow the tool holders to be swung past the center of the stock guide bushing for tool centering adjustments. Next, the tools must be centered. To center the tools, this centering scope is used. Located here is the large main focus ring. The purpose of the main focus ring is to focus the scope on the tool and guide bushing. The focus ring is rotated as needed for proper focus. Located here is the eyepiece focus ring. The purpose of the eyepiece focus ring is to focus on the inside display of the centering scope. The eyepiece focus ring is rotated for best focus. The display in the centering scope is a group of concentric circles. A crosshair pattern locates the center of the display. The purpose of the circles is to align with the inside diameter of the stock guide bushing for the particular job. The crosshair pattern will then mark the center of the bushing. Located at the eyepiece of the scope are these display adjustment screws. Depending upon the scope, you may have 2 or 4 screws. On the 2 adjustment screw type eyepiece, the screws are spring-loaded. Turning this screw counterclockwise will move the display down. Turning the screw clockwise will move the display up. This screw will move the display left and right. Turning the display screw counterclockwise will move the display to the right. Turning the screw clockwise will move the display left. This scope has 4 display adjustment screws. These screws must be used to move the display up and down. These screws move the display left and right. To move the display, one screw must be turned clockwise while its counter screw on the opposite side of the scope is turned counterclockwise. Located here on the scope is the scope leveling adjustment. The purpose of the scope leveling adjustment is to adjust any tilt out of the display. This is the scope leveling screw. This leveling screw lock screw must be loosened for adjustment. When the scope is mounted, the leveling adjustment screw rests against the machine frame. This is the electric power cord used to operate these two lights on the back of the scope. The purpose of the light bulbs is to light the tooling area during tool centering. The power cord is plugged into this outlet on the main operator control panel. Depending on the electrical cord on the scope, you may use either type of outlet. On the Model D2, the centering scope is mounted in place of the counter collet carrier plate. On the D4, the scope mounts in place of the drill turret. Place the centering scope in position. Plug the electrical connection into the operator panel electrical outlet. Place a piece of white paper behind the feed rolls. This will help define the inside diameter of the bushing. Adjust the two focus rings for a well-defined picture. Next, adjust the display adjustment screws to center the display. Check to see if the display is tilted. If the display is tilted, adjust the leveling adjustment screw. Lock the scope in position with the front carrier plate lock lever. Check that the display is still correct. Next, swing a tool into the display area of the scope. Align the tip of the tool with the vertical line of the crosshair. Turn the tool centering screw until the tip of the tool reaches the cross point in the crosshair. Swing the tool and check that the tip of the tool swings through the cross point. Then tighten the two tool holder set screws to hold the tool in place. Rotate the tool head and center the second tool in the same manner. Then unlock the front carrier plate lock lever, unplug the electrical connection, and remove the centering scope. Now the tool axial position can be set. The tool's axial position for most jobs will be set to be at the center of the axial adjustment range. This will allow any small changes to be made in either direction when necessary. To make axial adjustments, first loosen the axial adjustment lock screw. Turning the axial adjustment screw clockwise will move the tool away from the stock guide bushing. Turning the axial adjustment screw counterclockwise will move the tool closer to the stock guide bushing. With experience, you will be able to judge the axial position of the tools by looking at the position of the tool holder bearing located here. The farther the tool is adjusted out, the more bearing surface will show. You can also look into the tool head to make sure that the counterbalance units are riding on the middle of the tapered cone. Once the tools are at their mid-axial adjustment position, the stock guide bushing can be adjusted into position. Loosen the lock screw holding the stock guide bushing. Move the bushing to be approximately 2 to 3 thousandths from the tool used for cutting off. You can determine which tool is used for cutoff by checking your layout sheet. Look in the column labeled Description and Sequence of Operation. This layout sheet shows tool number 2 is used for cutoff. Check that the tool properly clears the bushing. Lock the bushing in place with a bushing lock screw. The cutting tool not used for cutoff is usually moved a distance of 5 thousandths further away from the stock guide bushing. This 5 thousandths clearance will allow the tool to come into position for turning a diameter before the stock is fed out into the tool. Lock down both of the tool axial adjustment lock screws. Now the tool's safe distance from the stock and the tool travel for each tool can be adjusted. This is the 0-point radius or mean radius of the tool cams. The purpose of zero point or mean radius is to indicate a point on the tool cams where the tool is set at a specified safe distance from the stock. For stock sizes up to 120 thousandths, the mean radius will usually be 1.77 inches. At 1.77 mean radius, the counterbalance is right on the middle of the tapered cone. The available travel from both tools is equal, and both tools may go past the center of the stock if necessary. For stock sizes above 120 thousandths, only one tool can be adjusted to go past center for cutoff. Both the available tool travels will not be equal. Some of the tool travel from one tool will be shifted to the other tool as the job requires it. To increase tool number 1's travel, the tapered cone will be adjusted back in the tool head. The counterbalance units will ride below the midpoint of the tapered cone. This will increase tool travel for tool number 1 and shorten the travel of tool number 2. The mean radius will be less than 1.77 inches. To increase tool number 2 travel, the tapered cone will be adjusted forward in the tool head. The counterbalance units will ride above the midpoint of the tapered cone. This will increase tool number 2's travel and decrease tool number 1's travel. The mean radius will be greater than 1.77 inches. When the tool cam followers are at the zero point of the tool cams, the index line on the outer thrust pin is an indication of where the tapered cone and the counterbalances are positioned. With the tool cam followers at the zero point of the tool cams and a mean radius of 1.77, the thrust pin is positioned to be flush with this plate. For a mean radius greater than 1.77, the index line is positioned into the machine plate. The amount the index line is positioned into the machine plate is a difference between the mean radius for the job and the mean radius of 1.77 inches. For a mean radius of less than 1.77, the index line is positioned out from the machine plate. The amount the index line is positioned out from the machine plate is the difference between the mean radius for the job and the mean radius of 1.77 inches. Before adjusting the position of the index line, check your layout sheet for tool cam zero radius or mean radius. You will find a column showing tool cam radius and another column showing degrees of cycle progress. For this job, zero radius is 1.830. Now check that the cam followers are at the zero radius of the tool cams. If not, hand crank the machine until they are. Loosen the micrometer lock screws for both tool number 1 and tool number 2. Turning tool number 1 micrometer clockwise will move the thrust pin into the machine plate. Turning tool number 1's micrometer counterclockwise will move the thrust pin out of the machine plate. Turning tool number 2's micrometer clockwise will move the thrust pin out of the machine plate. Turning tool number 2's micrometer counterclockwise will move the thrust pin into the machine plate. During the adjustment, you may have to work between both micrometers to achieve the proper adjustment. With the index line in proper position, both cam follower tips should be adjusted to be even. Tighten the tool micrometer lock screws. You must now set the tool a safe distance from the stock. The safe distance will be specified on your layout sheet. This is the tool distance setting gauge. The distance gauge mounts to the rotating tool head. Located here on the tool head are the mounting holes for the distance gauge. The distance gauge can be mounted in either of the two positions on the tool head. This is the threaded mounting hole and alignment pin hole. Located here on the back of the distance gauge is this alignment pin and mounting screw. This is the front of the tool distance gauge. Located on the distance gauge are two micrometers. Each micrometer has a lock screw. Before any adjustment is made, the lock screws are loosened. Each micrometer has gradation marks on the edge of the micrometer. This edge of the micrometer has a reference index line. Each gradation is an adjustment of 5/1000ths of an inch. Thread a piece of straightened stock of the proper size through the stock guide bushing. Clamp the stock in the feed rolls. Mount the distance gauge to the tool head. Make sure to align the pin on the back of the distance gauge to the alignment hole on the tool head. Tighten the gauge mounting screw. Make sure the distance gauge micrometer lock screws are loose. Swing a tool against the stock. Turn the micrometer screw until it just touches the tool holder. Note the position of the gradation marks and index line on the distance gauge. Now turn the micrometer to move the tool away from the stock. Turn the micrometer 4 full gradation marks past the index line. This will move the tool 20/1000ths away from the stock. Lock the tool head in place. Hold the tool securely against the distance gauge micrometer. Move the roller end of the counterbalance unit to contact the tapered cone. Tighten the counterbalance lock nut. Turn the lock nut toward the small roller end of the counterbalance unit. Unlock and rotate the tool head to access the other tool counterbalance unit. Swing the tool against the stock. Turn the micrometer screw until it just contacts the tool holder. Note the position of the gradation marks and the index line of the tool distance gauge. Turn the micrometer to move the tool away from the stock. Turn the micrometer 4 full gradation marks. Lock the tool head in place. Hold the tool holder against the distance gauge. Move the roller end of the counterbalance unit until it contacts the tapered cone. Tighten the counterbalance lock nut. Turn the lock nut toward the roller end of the counterbalance unit. During operation of the Escomatic machines, you will have to remove, sharpen, and replace cutting tools. To remove the cutting tools which need sharpening, loosen the two tool holder lock screws and pull the tool out. You may have to turn the tool centering screw to force the tool out. This is the tool sharpening holder. Insert the tool into the triangular hole and push the tool all the way back. Lock the tool in place with the two tool lock screws. Next, install the sharpening holder on the angle micrometer sharpening fixture. The tool lock screws should be facing up. Lock the holder in place with the fixture clamp lever. These are the angle micrometer adjustments on this fixture. This angle micrometer should be adjusted to match the face angle of the tool. Check your layout sheet to find this face or rake angle of the tool. This second angle micrometer should be set to 0. Loosen the tool face angle micrometer lock lever and rotate the fixture to match the tool being sharpened. Tighten the angle micrometer lock lever. Next, loosen this fixture lock lever. The lock lever locks the fixture to the feed bar. Slide the fixture left or right and move the tool into the wheel until the face of the tool rests against the grinding wheel. Tighten the fixture lock lever. This is the fixture forward stop. The purpose of the forward stop is to limit the forward travel of the fixture toward the center of the grinding wheel. This is the forward stop lock screw. Loosen the lock screw to make any adjustments. This is the forward stop adjusting screw. Adjust the stop to keep the tool from going past the end of the grinding surface. Turn the coolant and the grinder on. Aim the coolant at the grinding wheel where the tool will meet the wheel. Swing the tool into the grinding wheel. Continue to swing the tool on and off the grinding wheel. Increase the feed into the grinding wheel with the feed bar micrometer. Increase the feed only when the tool is off the grinding wheel. Continue to grind the tool face until you have removed 2 to 3 thousandths from the tool face. Stop the grinder and shut off the coolant. Remove the tool sharpening holder from the fixture. Inspect the tool cutting edge for any chips or burn marks. The tool edge should be clean and sharp. Remove the tool from the holder. As you sharpen the tool width will decrease. Check the width of the tool. Be sure the tool width is still within tolerance. Clean the tool holder area and replace the tool. Then recenter the tools. This completes your lesson on removing, sharpening, and replacing a cutting tool. You may watch this tape as many times as necessary to fully understand the material. When you have finished, return to the operator booklet for your next step.